I'm hoping that you've also seen this lesson before, dealing with scatter plots and correlations. So it should be pretty easy. So the question for the day is, what are correlations of scatter plots? We're going to be creating scatter plots and then also finding a line of best fit and then trying to find the equation of the line. So it all kind of builds on what we've been doing the past couple of days in 3.4. So the only one word we have for today is a scatter plot. So what is a scatter plot? You've probably seen them before. A scatter plot is a graph with a bunch of data points and XY points. And then we have different kinds of correlations. So one is a positive correlation where y tends to increase as x increases. In other words, that's like saying you have a positive slope. And I'll try to give you an example of that. If you have a graph and you have a bunch of dots and they all tend to be kind of going upwards, that is called a positive correlation. Just the opposite, you can do the opposite here, so have a negative correlation where y tends to decrease as x increases. So the y values are going downhill. Call that a negative slope. An example of that would be like having a bunch of dots, but it tends to go downwards like this. So pretend those are a bunch of dots. It's kind of going down. And then you have a third option, which is that you have no correlation. This is when the points show no obvious trend at all. So for example, you could just have dots everywhere, and then there'd be no point in saying like that it has a positive or negative correlation because they're just everywhere. No trend, as I call it. So those are three types. The first thing we're going to do is just look at a bunch of scatter plots and identify whether it's positive, negative, or no correlation. So describe the correlations using the above vocab. So if you look at this, this is definitely going up and to the right. This is going to be a positive correlation. This one's going downhill. This is negative. Don't think I have to spend too much time on this. It's pretty easy, and I hope you've seen something like this before. C is definitely a no correlation, or you can say there's none. I'm going to say no correlation. D, if you look at this one, it kind of looks like it's going downhill. These dots here look like they would kind of be like outliers. I think the trend is kind of like they're all going downhill. So I would probably say this one's negative, but I could see why you might think it's a no correlation. But I'm going to call this one negative. It looks like it's more so sloping downwards. E, definitely going down again. So this is negative. F, going down again, negative. And the last one would be going uphill, so that's positive. Pretty simple. We have some more fill in the blanks. So now we're going to talk about drawing something called a line of best fit. So in general, when a scatter plot is drawn, the points are usually not linear, which means they do not just make one straight line. Thus the word scatter plot, because they're kind of all over the place. But if there is a correlation visible in the pattern of points, so like if it's a positive correlation or a negative correlation, then we can draw a line. We can sketch a line through the scatter plot to represent the trend of the scatter plot. This trend line is called, what you're familiar with, hopefully, a line of best fit. They also call it a regression line. But it means the same thing. Regression, line of best fit, means the exact same thing. And so when we draw a line of best fit, it is just an approximation of drawing a good straight line going through a bunch of points. But, some people may not draw the same line as everybody else. So it's very possible that two different people will draw two very different lines on the same scatter plot. In order to avoid this, we're going to try to follow these two rules down here of when drawing a line of best fit. We're going to try to have just as many points above the line as there are below the line. Try to have just as many points above the line as below the line. That's like the line that you draw. And you also want to try to draw a line through as many of the middle points as possible. So hit a bunch of points if you can, and try to go through the middle of all the points, of all the dots that are there. So we're going to practice drawing lines of best fit next. So for example 2, we're going to draw a line of best fit if it's possible. Try to follow the rules. Going through the middle, hitting a bunch of points, and then seeing if there's the same number of points above and below the line. Should be similar. And then also we should do whether it's positive, negative, or no correlation. Let's do that part first. This is definitely going uphill, so this is going to be positive. Positive correlation. This is going downhill, so it's negative. And the last one we have here, there is no correlation at all, so no correlation. So I'm not going to be able to do it too well because it's best to use a ruler for this. So I'm going to draw a line of best fit as best as I can through the points here. I think I'm going to be able to go through like maybe 4 or 5 of them. So I'd probably start about here and then go up. Oh boy. Maybe like this. I'm losing it a little bit. Like that. That would be my line of best fit. It's a positive correlation going up. A line of best fit for this one going down negative. I'm going to try to hit 1, 2, 3, 4. I'm trying to hit maybe these 5 points here. Oh, 1. Oh, goodness. Again, if I drew a straight line, I would hope to hit at least 5 of those points. So let's count and see. I hit 5 on this one, and there is 1, 2, 3, 4, 5, 6 on the bottom. 1, 2, 3, 4, 5 on top. That's not too bad. Over here we have 1, 2, 3. Would I have hit that one? No, I probably wouldn't have hit that one. 3, 4, 5. I'm going to say I hit that one. 5 on the bottom, 1, 2, 3, 4, 5 on top. And I end up hitting 1, 2, 3, 4, 5 as well, if this would have been a little bit straighter. So those are decent lines of best fit. Going through the middle, hitting as many points as possible, and then also looking at the other data points above and below it. So the first 2 problems you're going to do is a team huddle, where you're going to plot the points yourself and then see if there's a correlation. I'm just going to go ahead and tell you the answers for each one as far as what kind of correlation it is. Once you plot the points, I hope that you can see that this is a no correlation. There's none. So you'll see a bunch of dots everywhere here. You can plot them yourself. The second one, I believe, is negative. And once you plot these, I think you see a bunch of dots that are like kind of in the same row. I think it's like here, 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 here. I don't really know for sure, but once you plot them, then you can like see it draws a nice straight line. That's for you to try and see if you can come up with that. We're going to do one last thing, which is now look at a line of best fit and make an equation from it. So we'll do 1 or 2 examples here to finish this off. Using the graph in part A, find the equation for the line of best fit using the following steps. We're going to draw a line of best fit, which I think we already did. Going back to example 2. Let's go back there. Here's example 2A. We're going to draw a line of best fit. Already did that. What's the next step say? Part B. Choose 2 points that lie on the line of best fit. Perfect. Let's try that. So I'm going to pick 2 points that are on your line. You have to pick it on your line. So I'm going to pick 2, 5, which is right there. And how about this point here? 8, 8. So 2, 5, and 8, 8. Okay, if this thing would actually work. 5 and 8, 8. You can pick any points you want, actually, as long as you pick points on the line. Has to be on the line. Then let's do what we normally do. We're going to find the equation through these 2 points by doing the slope, point slope form, and then we'll finally solve for slope intercept. So that's the last 3 parts here. Stuff that we've been doing the past couple of days. So our slope, in case you forget the formula, it looks like this. y2 minus y1 over x2 minus x1. And plug the numbers in. x1, y1, x2, y2. So this would be 8 minus 5. And the bottom would be 8 minus 2. So we get 3 on top, and the bottom is 6, which is the same thing as 1/2, or you could use 0.5. It doesn't really matter. I think I'll keep it as a fraction. Either one's fine. Substitute this into point slope. Here's point slope. It's y minus y1 equals m times x minus x1. And we have x1 and y1, just got to plug in the slope, which is 0.5. So y minus y1, which is 5, equals, I'm going to use the fraction actually, 1/2, x minus x1, which is 2. So that's actually the answer for part D, writing it in point slope. But now I'm going to answer part E, which is solve this for y. So I'm going to distribute that, and I'm going to put it over here. A little bit more space over here. Well, I guess it doesn't matter. Y minus 5 equals, distribute the 1/2, you get 1/2 x. 1/2 times -2, well, half of 2 is just 1, so it's going to be minus 1. And that part's done. Then we just add a 5. There we go. So that goes away. So in slope-intercept form, it's y equals 1/2 x plus 4. Sorry for the terrible writing. Using this mimeopad is tough. It's not really registering that well. I'm going to go back and check and see how well this actually looked for 1/2 x plus 4. So we're going to cross the y-axis at 4, and then our slope is up 1 over 2. So I'm just going to go back and check it, see how close it was. So we crossed at 4, as you can see. It's pretty close to being 4, right, where my line was drawn. And then if I go up 2 over, or up 1 over 2, I keep hitting the line. Look, up 1 over 2, up 1 over 2, up 1 over 2. You can keep doing that. So it actually does work. That's your slope, and that's your y-intercept, and then there's your equation. As long as you pick the 2 points on your line. So the last thing you have to do is do one yourself, where you draw a line of best fit, and then pick 2 points, and then go through the same steps. I might go through it real quick, but I would like to end this video soon as well. So this one can be tough to draw a line of best fit. I don't know what the best option is here. It's just tough. There's a lot of different things you could do, and I don't know. I'm just going to draw a line like this. And let's say I touch, a couple of these points in here. This one's also tough because you have to estimate these points. So I would do something like, well, let's just pick this point here. Oh boy, that would be like 0.5 and 39. I might need a calculator for this one. And then I'm going to pick another point. Let's say I hit this one here. That would be, let's just say it's 2.5. This is going to be an estimate, so it's not going to be perfect. 2.5 and probably close to 60. X1, Y1. So I'm just going to quickly go through this and not really talk in depth about it, because you should know how to do this. 2.5 on the bottom minus 0.5. And 60 minus 39. So that's like 21 over 2. Right? 2.5 minus 0.5. So this is actually 11.5. Wait, 10.5. Hold up. 10.5 is your slope. And I think that if you draw a similar line to me and pick points that are a decent estimate, you'll get close to around 10 as your slope. So if you have like 10, 11, or 12, that's pretty good. Using the point slope form, we would do y minus y1, which is 39, equals our slope 10.5 times x minus 0.5. And then you're going to distribute this. So this is actually the answer for part D. The work down here, converting to slope-intercept form, is what I'm doing now. So 10.5 times x is 10.5x. 10.5 times 0.5 is 5.25. And then we just have to add the 39. Be careful, though, because we're adding 39 to a negative number, so it's like taking 39 minus the 5.25. So that would be what? As a final answer, y equals 10.5x plus 33.75. And there's your answer. I don't know how good that is as far as the slope is concerned because I can't count blocks on here, but the y-intercept is 33.75, and that's not too off from where my point is. This goes by tens, so this is 30, and it's a little bit higher than that, so maybe this is like 33, 34-ish, so it looks pretty good. There is also a homework that goes with this, and you're supposed to do the front of it. There's 2 questions that are exactly like this, but you have to plot your own points and then draw your line and go through the same steps. That's it. The homework is problems are 1 and 2.